Hey everybody, this is Larry. This is day 8 of the December Advent of Code. I guess it's always in December. Hit the like button and subscribe button, join me in Discord. Let me know what you think about today's problems. Part 1 or part 2 or whatever. Yeah. There's a minute left as you can see. I'm gonna change my thingy. So to my setup, what am I gonna say? Yeah, I mean, there's still 50 seconds left. Let me refresh. Oh yeah, the format, as it should be every day, unless I'm like having a stroke, is that I'm going to solve the problem live, and then we'll do a quick review afterwards. Feel free to fast forward, watch it on 2x, whatever you need to do. Skip ahead, right? Yeah, I also took a nap before this one, but I don't know. I woke up 3 minutes before instead of 50 seconds before, so hopefully that means I'm more prepared. 15 seconds to go. Yeah. I'm gonna start the time. I start the timer early because I only have like, whatever, right? 4 3 2. Right, let's go. 1. Right, let's go. Okay, so we have these. Okay, that's 3. So we have 3D coordinates, maybe. Okay, straight line distance. What's that? Orlean, okay. This is like minimum spanning tree. Yeah, okay. What am I going to do with them? I don't know. How many are there? 1001. Am I misunderstanding this? If there's 1001 after 1000. Oh wait. Yeah, I don't get it. Oh, nothing happens. Okay, so I guess that's what they mean. Okay. I mean, it's n squared, it's fine, right? So, yeah. Yeah, okay. Yeah. I am too slow today. I think I've been saying that a lot anyway. Probably need better things in general. That's not even, it's supposed to do it the other way, but whatever. Okay. Yep, okay. Yep, okay. Union find. I don't know if I have union find set up actually, but we can write it. Let's just write n. Probably smarter people have it written already. Man, I am so rusty. I feel like I usually write this pretty faster. Of size. Okay. Distance. Okay, and then now, yeah, I will just in a weird way. Yeah. Because it doesn't work for testing. Why is that too slow? Why is that too slow? That should be fast. Okay, I mean that's not fast, but it's not slow. Actually, let's try. What is that? After 10 shortest connections. Okay. 542, but I am not producing that. What am I producing? R and cipher. Five, 4, 2. How am I so bad at this? This is just minimum spanning tree. Why is this not right? Why am I so bad? One. Doesn't even make sense. No, I didn't sort it. I'm going to sort it. 322. Why? I am so sad. Because I don't know why I'm debugging. I shouldn't need to debug this. This is so messy. Okay, so that's true. Oh, and then it does the reverse of it. I see. I am dumb. Okay, so that's why. I thought about that. I thought, but okay. 542. Okay, that's right. Yep. Okay, I can't believe I make such a new mistake. Whatever. That's not right. It's the first element of the. I have to change this to 1,000. I don't have things that are okay. That's not quite. Oh, oh my! I don't know how I'm so bad at this today. Such a new mistake. Yeah, I mean this is yeah, I mean copy and paste everything. I guess so. That's good. I mean, part 2 is trivial. I mean, you kind of expect it. Maybe the other way. This way. Because we want A, B, X coordinates. I'm so bad, so bad. Why is that taking? I guess it makes sense. That takes so long. But I don't know. I feel like Python is slow, but it's not this slow. Just end square, hey? It's just so while loop union square. I forget what it is. Okay, it shouldn't be slow though. It should be even fine, right? It's only 1,000,000 things, right? It's 1,000 square. How can it be so slow? I am just maybe confused. Let's run it on a test thing first. Maybe infer loops in a different way. I mean, they're definitely. I definitely have a bug somewhere, which is maybe the story of today in general. And coordinates and components greater than 1. Union fine. AB. Okay, that's fine. Why is this I? Oh, because it used to be a I loop. I am so dumb. So dumb. 252. Okay. I mean, I was like, this is slow, but it shouldn't be this slow. Yeah, I mean, stop the clocks, everybody. But this is really sad and ridiculous. This is like a textbook minimum spanning tree on the Cartesian plane, 2D plane. Or actually, I say 2D, knowing that there's 3 coordinates on 3D plane, but 3D plane, 3D space. Sorry, I'm just catching up breath real quick. I don't know. I think I'm more disappointed about it more than anything. This is pretty straightforward. Pretty I want to say whatchamacallit, like as textbooks as it gets for minimum spanning tree on a plane. I don't know. Like I did in 13 minutes, 14 minutes on both components. I don't know what the breakdown is actually. But the first part I definitely could have done. I don't know if I typed everything correctly and not dumb. Like less than 5 minutes when I'm peak, and part 2 probably less than a minute. I don't know. I mean, I copy and paste wrong, kind of. I don't know. I don't know if you say I'm wrong. I just kind of changed it to a loop, but then I just forgot certain things. So ship in less than a minute if I was actually like, I don't know anymore. But yeah, okay, so let's go over part 1. Part 1 is I don't like on I don't my hesitation is I don't know how to explain it. I'm not gonna lie. Why I'm saying that is because it is just there are 2 components, right? One is calculating the distance, I suppose. Yeah, and that's actually very basic. There's a link to it, and like that they gave you about Cartesian distance or linear distance. I say Cartesian. I'm just confusing everything all today. There is in Cartesian space, right? But in any case, yeah, and then the minimum. I mean the other component is a textbook description of minimum spanning tree. Specifically Prim's algorithm, right? Oh, is it Prim's? No, Cusco. Sorry, I do. No, it's Cusco for sure. It wouldn't make sense if it's Prim's, for or at least the way the rest of the problem describe it. No, it's Cusco's algorithm. Hope I'm saying that right. Right, and you terminate after 1,000 loops or whatever, and yeah, and that's it. And then you just get the component sides. You have to the way that it's standardly done is by using union find, right? And this one you have to know the size, so you keep components on the size or size on the components. Man, I can't even English today, let alone code. But yeah, this code does that. You have to remember the sort, but otherwise. And then part 2 is you just loop until completion, which is the other actual part of MST, right? What minimum spanning tree? What minimum spanning tree? Yeah. And by done, I don't know why I kind of forgot the I in here. Yeah. I think I usually don't write it this way. I don't know how I usually write it. How do I usually write it? Why is everything confusing today? Why am I doing something different today? But yeah, yeah, right. Yeah, you just run it until you have one component left. You can think about it. There are a lot of different ways about knowing about Cusco, minimum spanning tree, and stuff like that, and how they all relate. So it does require some understanding, or I want to say deep understanding, but maybe it's not like it's something that you have to have a good understanding of, even if you like by the time you're like an intermediate competitive programmer, I would say. But yeah, it's just about understanding how Cusco works, and if you had implemented part 1, I don't even know. I mean, I guess you can do it without all the algorithmic Farego underlying for part one. Maybe you could brute force it a little bit in some way. But if you had just done it Cusco, in which it is like almost like a textbook match in a way, then part two should be also pretty straightforward as well. And I don't know if there's much to explain about it. I think what's left is complexity, right? You have end nodes, and square edges, and and there are maybe algorithms that you can play around with. Yeah, maybe, but I don't know them that well. I mean, you could, like, for example, you could get the closest point and then log n or something. But that's like a whole other thing with divide and conquer. But I don't know how much that helps actually. But yeah, with n nodes, n square edges, sorting on n square edges is v square log v square log v square, which is technically v square. Did the light go? Oh man, my light is having issue too. My light's unhappy with me either. So that's gonna be n squared log n, right? Log of n squares, you go to log n, or O of big O of log squares, you go to big O of log n if you want to be more precise. And then everything else is just a loop on n square, right? Or this loop. So that's going to be your complexity v square log v, and it is a complete graph unless we do something smart or something. But yeah, like I said, most of this problem is pretty textbook, part one and part two. So that's all I have for this one. Let me know what you think. Thanks for watching. Let me at least try to put this, or I think this is mostly or actually on the same page. Yeah, okay. So this is part two. So yeah. That's all I have for this one. Let me know what you think. Thanks for watching. Goodbye from Ushuaia, Argentina. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.